And when you talk about additive manufacturing in this context, in most manufacturing companies in general, we'd like to use the phrase Big M. Big M manufacturing is everything you do to conceive, design, produce, inspect, test, field, support a disposable product. So why is that big picture important? Well, it's important because in this technology, the real challenge begins with how you design for additive manufacturing or 3D printing. And we tend to use the phrase interchangeably. So we clearly are having a growing shortage of technicians to operate the equipment on the factory floor or in the labs, wherever it might be. But the bigger shortage is the shortage of engineers that know how to design for this technology. So you have to have that holistic perspective on this. So going to the next slide, if this works. Did it work? It did. It's good. I think I'm going to have to read some of that. That may be an eye test. This is the list of the 7 different main categories of additive manufacturing processes that have been identified by ASTM in their standard on additive manufacturing processes. And just to read quickly down the process type list, there's powder bed fusion, there's direct energy deposition, there's material extrusion, vat polymerization, binder jetting, material jetting, sheet lamination. And then it talks about the different materials that you can use and then the different market applications. And to put this one in context, I finally realized the way to really convey to the general public about additive manufacturing and its scope and breadth. We have a lot of people who come to us who I'll get approached, Ed, I want to get involved with additive manufacturing. I think it's a really growth area for my business, or I'm concerned that my business might be threatened by this technology. And let me just quickly point out, it's not going to replace all of manufacturing technologies. It's just another tool in the toolbox, although a very powerful tool. And just to make an additional point about that, in a lot of additive manufacturing, you still do post-processing with traditional machining, subtractive manufacturing is now called. So when people approach me, I want to get involved in additive manufacturing. That's like telling me you want to cook dinner. What's your heat source? Using electrical resistance, or you're using lasers, some other mechanisms of generating heat. And what materials are you going to use? Are you going to use plastics or polymers? Are you going to use metals? Are you going to use ceramics? Are you going to use organics? The 3D Systems trade show printed custom Oreo cookies, dollar filling. Or are you going to print using human tissue or animal tissue body parts? So the market, when you think in terms of different applications, you can do mechanical parts, and we've got several one demonstration in the back. You can do printing of electronics. You can do the printing of commingled electronics and mechanical parts. You can do hardened parts. You can do food, and again, body applications. So it's very ubiquitous, very cross-cutting. So who are we? We are a public-private partnership. We are mission-driven, and our mission is to accelerate the adoption of additive manufacturing technology in the United States sector to yield innovative products and increase domestic manufacturing competitiveness. We recognize we're in a global competitive environment in manufacturing, and we want to strengthen the U.S. position in that global competition in manufacturing by leveraging this incredible technology and all the different capabilities that it has. Again, as a public-private partnership, we are comprised of public members with substantial federal, private industry, and academic investment, multi-agency participation. So our principal federal partners are the Department of Defense, Department of Energy, NASA, the National Science Foundation, Department of Education, Department of Commerce, and we've recently added 2 new members, Federal Aviation Administration and the Food and Drug Administration. And there's conversations with some other federal agencies because this is such a cross-cutting technology. We're currently 169 members. We've been growing over the last 2 years at a rate of about 44% per year, which shows you again the interest impact that this technology is having on the manufacturing sector in the United States, but also 38 premier universities that are engaged as members as well. A piece that is sometimes a little bit confusing. American Makes, the National Manufacturing University Institute, is not a legal institute, so it's operated by the National Center for Defense Manufacturing Machining. It's a not-for-profit 501c3 company. So all of our employees, including myself, I'm a vice president for NCDMM. So what do? We do robust additive manufacturing technology and workforce education road mapping as our first step. I think it's a fundamental to what we're doing. There we go, thank you. Every time you push the button doesn't mean the right thing happens, right? The criticality of doing the road mapping and the secret sauce, if you will, as a business model for an innovation institute, when you pull together academics, universities of all sizes, businesses of all sizes, and the federal partners representing all these different sectors, and you start talking about what they need, what are the barriers, what things need to be resolved, what needs to be solved, and then put that in a roadmap, that defines our investment strategy going forward. And then when we're doing cost share, which is a key element of being an innovation institute, you already know up front that the universities and the industry are willing to match the investments from the public side. When we do technology development, we transition the technology to companies with real products. Clear observation is you don't score points until the technology is implemented and being sold in products or equipment and materials. Workforce and education outreach, I'll share more in a moment, and then innovation factory services. And in terms of size of impact as the first institute, as a result of the project call that we have out on the street right now, once we make those awards, we'll have an investment portfolio of $96 million. Now, I want to just sort of, by comparison, Singapore just stood up a center for 3D printing in 2015, and their investment initial kickoff funding was $150 million. A little bit larger than our $96 million. And our $96 million, more than half of that is cost share. So you can do some really incredible things. You can see, just take a quick look at the slide on the left. That's called a brain gear. All of those little pieces are meshed together, and you can take any one of them and spin them. And the cool thing is it was printed, it was not assembled. I have a smaller one. This is a herringbone gear assembly. You can see it spins nicely, and move it back and forth. It doesn't come apart. This was not assembled. It was printed as an assembly, so some of the things you can do uniquely. And then you see on the right side some cross-section of a blade for a jet engine. But there's some dirty little secrets, lots of things to be dealt with and solved. One of the key things we're dealing with as a major initiative, the technology is growing faster than the standards and specifications. So what do you do about that? You have to have the standards and specifications to qualify the parts, particularly if it's flight critical for FAA, for NASA, et cetera. So we've established a working group and an advisory group to deal with this. We've partnered with the American National Standards Institute to provide some organization, some coordination to get all the right standards in play, be able to lay out a nice roadmap of what additive manufacturing standards exist, what needs to be created, and then which of the standards developing organization will do that. And then we help them staff those writing tasks from our membership, from our industry membership, from our academics and so forth, to accelerate the standards that are desperately needed. On educational outreach, just some quick highlights of the things we're doing in workforce. One of the first things we did was establish a additive manufacturing certificate program working with the SME and the Milwaukee School of Engineering, so that those that are going to be doing technician work can establish their credentials and capabilities through some training courses and pass the test for a certificate in additive manufacturing. We also then partnered with Deloitte University Press and launched a massive open organization, massive open online course. So picked up a new acronym, MOOC, and it's focused on business leaders' use of the additive manufacturing, and so far more than 14,000 individuals in the United States have taken that online course. The next piece I want to share is the Robert C. Byrd Institute received a grant from the Department of Labor, and we are partnering with them. They're partnering with us, a nice synergistic relationship to expand the use of apprenticeship models for education in additive manufacturing. And then the last one is one that I think is, to me, very, very important, and that is we received a grant from Google.org, and we're partnering with the U.S. Department of Veterans Affairs to develop training for returning military veterans in additive manufacturing to make sure they have a good, solid career, well-paying jobs in additive manufacturing. Just a little side note in historic perspective. One of the things that really fueled the growth in the solid manufacturing industry in the United States was men and women coming off the farm. They were already innovative, they were used to doing repairs and so forth, and they were the staffing for all the engineers and manufacturing employees. Well, that's not happening so much anymore. So where are we going to get the next wave of talent to do additive manufacturing? Veterans. They're already innovative, excellent job ethics, etc. So I think it's really important, and I think we as a nation owe them the careers in this technology. We also do STEM education, science, technology, engineering, manufacturing, education, working with the youth. We partnered with First Robotics. One of the cool things that I realized early in my involvement in this technology is you can use additive manufacturing to teach. You can make mathematics fun by demonstrating what you can do with perhaps printing a formula, etc. So our vision is to get printers in all the schools in the United States. And just again for comparison in the global competitive environment we find ourselves, China made an announcement last year in the fall. They are deploying 400,000 printers in all of their elementary schools in China. Look out. Some success stories, rejuvenating tooling. We spent a lot of time on this. Just some quick data. Extending the die life by 25%, cut the cycle time from 26 weeks to 2 weeks, 10% cost savings. Changing the equation to, again, reestablish a competitive die business, tooling and die business in the United States and maintain it in the United States. And then the next one, we actually have a presentation in the corner. I want to give a shout out to Brandon LaMancha from Hometown Products, and he can give you the great details on this project. It's led by Youngstown Business Incubator. I also call them Landlord because we're in downtown Youngstown, Ohio. And some of the results in working and applying this technology in the foundry business. We're making castings. They reduced the cost of materials for printed sand molds and cores by over 80%. Speed to market increased. They went from 12 plus weeks and often months to 3 weeks. They increased affordability of more quantities of castings, and in that process improved performance. It's a rare technology, it's a rare investment where you can get cost, schedule, and performance all at one time, and this technology is delivering that capability. Last thing I want to touch on is the value proposition of a public-private partnership. On the public side, as a taxpayer, I'm one of those. I think you all are also. When we have the federal government invest $1 million in research and development, and we match that with cost share, the taxpayer is getting $2 million worth of research and development. That's a good deal for the taxpayer. If you're one of the investors putting up the cost share, and make the model very simple, if you were putting up $200,000 out of a team of 5 of cost share, because you have to have this $1 million of cost share, your return on investment of $200,000 is $2 million worth of research and development that you can use in your product. So we think that's a really good model for business going forward. We think the public-private partnership model makes a lot of sense.